to another episode in Python programming from beginner to programmer. In this series, I hope to level you up with all that I know about Python programming so that it becomes a very powerful tool to help you in your Python programming and perhaps even your career. In this particular session, we want to talk about a very important aspect of programming called variables and values. For seasoned programmers, this is very bread and butter, and it almost comes subconsciously whenever we want to design a program to do certain tasks and achieve certain goals. We have to think about variables and values. There's a lot to talk about that, and it is this session that I precisely wanted to at least bring to your foreground attention how important these silent aspects are. It's not going to be a long-winded session, even though we can make a huge study out of it. But paying attention to these aspects will go a long way in helping you clear and effective programs. So first topic, variable names. How do we name variables? What are variables in Python? Value constants and literals. What are they? Values being constants, or else are they not constants? What are expressions? How are expressions being made or written in Python? And finally, the basic operations on those values. So the very first encounter with Python quickly shows us the need to have values being stored in memory. So one of the important aspects of programming is to be able to handle data. Now, data will be values in Python, and we want to know how to represent those values. The whole idea lies on the concept of variable. So what are variables? This here, let's just quickly look at a simple Pythonic statement. X equals to 1, 2, 3. This is a assignment statement assigning the value, this integer value of 1, 2, 3, to this variable labeled as X. The concept that I will sort of introduce you to think about the relationship between variable and value is this container here. So we don't have 1, 2, 3 containers, we have billions of containers. For example, if we are dealing with big data, we have a lot of data, and we don't necessarily store all big chunk of them into one location. We must spread them out, right? So we have a million containers, and we fortunately don't refer to each container with a numerical address, like IP address, like your national identity address value. We point to each location, each container, with a label. So imagine this plastic container, and it's very bland, nothing to identify, and we stick on a label called X. So every time we want this container, we won't say, the third one on the left or something like that. We just say, fetch me the content of X. And Python will know, right? So which container to go to, even though there are billions of them, Python will just bring out that specific one that's labeled X. Now, because of this concept, you straight away recognize that, hey, does that mean that I cannot have two containers having the same name? Very true, right? Very true. That's exactly the point. That when we have this concept right, this analogy right, then a lot of questions will answer themselves, right? So if we tell Python we want the container because we say variable X, the label X has better be unique amongst the billions of containers, and indeed that's true, right? So when we do this equal sign, it's actually an asymmetrical operation. Python will look at the right-hand side value and stores it into the container, puts it into the container X. Each container must have only one value. What happens when we store another value into X? What happens when we do that when there's already a 1, 2, 3 value inside? Well, Python is not going to automatically chain them up like 1, 2, 3, 4, 5, 6. Neither will it add, neither will it subtract or multiply, because those operations are not unique and may be different in different cases. So Python will not take any default action. Instead, like in many other programming languages, when we do a second assignment, the new value will overwrite, kicks out the old value, and the new value becomes the only value that is being stored in the container. Now you might ask, what happens to the old value? Now you either back it up, right, and by reassigning 1, 2, 3 to somewhere, some other container, some other variable name, it gets vaporized, basically gone, right? So that's the beautiful part of digital world. It gets vaporized. It is totally unretrievable. Python has no more idea, no more memory about the old value 1, 2, 3. Okay, all right. So let me just quickly say again. Variable x means that container having the label x outside, and assign the value into x means x equals 1 to 3 means put the value 1 to 3 into the container. And when we reassign, the new value will totally overwrite the old value, and the old value is gone. That is for storing value. Now, variables are very useful and powerful because they can be stored and they can also be retrieved from. So we can access a variable in the sense of just talking about it, mentioning it, print. In global namespace, x equals to, give me the value of x. That's what we are trying to tell Python. So by just putting a place where the value is needed of container x, we just put an x there. Very, very efficient, because simply putting a label x there is sufficient. And mentally, we can think of, hey, in global namespace, x equals to 1, 2, 3. We can mentally think about that. And that's very nice because it's very visually attractive to see that they just place side by side with each other, and that will be the result that we actually get from Python. Right, so there are two ways to handle variables. One is storing into it with a value, and the other one is retrieving from it. Now, the act of retrieval is a bit intriguing because it's going to deviate from our usual sense of taking that content inside X and returning to the whatever calls it. What happens to the value inside? Now, in this case, of course, it's a copy of that. So when we retrieve it, that value is being accessed digitally, and that means that a copy of that value is being sent to wherever is needed, in this case, to be printed out. And the old value, or rather the same value, is still there. It's still there. So 1, 2, 3 is not like gone. It is just staying there, whose photostatic image gets sent to the place where it is being needed. So here. Right. So this 1, 2, 3 does not invalidate or delete the value of 1, 2, 3 inside the X container. When we overwrite it with 4, 5, 6, that action does delete away the old value. And so we can read it multiple times, 100 times, 1 million times, and X will still have the value 4, 5, 6. Now this sounds basic, but if you don't know, you don't know, right? And it could mean that, oh, that means the 4, 5, 6 is gone when we read it once. No, that's not true. Okay. Now, what happens if we reverse the operation? If we try to access a variable before it is being stored with the value, that's going to be tried out here. We're going to read or ask Python to read from the container called y when we have not even labeled any container y yet or stored any value into it yet, and it will come back as a name error. So we put it inside try and accept, right, knowing that it will generate an error. So we should see that this line cannot be executed at all because y is undefined. There's no idea what are you talking about. Which container? They're all bland. No container has been named y yet, right? So it will return a name error. I cannot find the container called Y. So don't even tell me to retrieve from whichever container. So we should see D colon because there will be an error, and try will catch that error, and it will send Python to execute the exec as we discussed earlier on in the um, control flow sequence of Python in previous video series. So let's just try it out and see. So we do a copy and flip it over, and we can do it here, right? And every time we copy from PDF, there's always a need to check that the quotation marks, they are the worst offenders. It will quietly invalidate your Python statements because they're not the proper quotation mark, they're the stylish quotation mark. And that's not recognized by Python as a proper quotation mark. Okay, so we'll do that here. Okay, after adjusting for the line breaks, we see that Spider has correctly detected that we are accessing a undefined variable. That means we haven't even labeled the container Y. Haven't even done that. And we try to think that there is a container called Y, and we say, give me the value of that container called Y. Of course, this example is contrived. I made it up, but oftentimes when we debug long programs or modules, we might accidentally delete the original definition of Y, the original initialization of Y, and find that we are in this case. Right? So it is an error to reference a variable before it is being defined. So a variable is defined by having a value being stored into it. So this is a bit unlike other very stringent programming languages like C++, Java, where you must define the variable in a way of typing it and all that stuff. So here, very simple. Python just says you define a variable by having a value being initialized to it. That's all. So when we run it, what happens? Just want to clean up everything so that it's clear. All right, let's run it. Okay, good. So we see at first x is 1, 2, 3 because of this, and we ask Python to access the container called x. So Python goes to that container, found the label to be x, found that the value inside was 1, 2, 3, and replaces this x with 1, 2, 3, and that's what is being printed. Then we overwrite the value of x with 4, 5, 6, and then we basically print the same thing again. So same programming instruction, same statement, causes the value of x to be printed out differently because we have previously overwritten the old 1, 2, 3 with 4, 5, 6.